In the last two classes, we've learned how to solve quadratic equations by graphing or by factorizing the quadratic. While we can use a graphing calculator to solve a quadratic equations, the fact is sometimes we don't have a graphing calculator, and you may want to create a table of values to do it. But it takes time to create a table of values, plot the points on the graph, and then identify the x-intercept that way. And there are also times when the quadratic cannot be factorized. So we want to come up with a way to solve a quadratic equations where we don't have a graphing calculator and the quadratic cannot be factorized. Here today, we're going to learn this method that would allow us to do just that. We will solve a quadratic equation by completing the square today. And the advantage of it is that we can solve our equations and try to come up with our answer in exact values. So even if you can only do it by a graphing calculator, you can get the x-intercept with exact values. And for those of you who want to study engineering or science, you will eventually find how nice it will be if your numbers is in exact values. You get to avoid a lot of unforced error when you are trying to build a bridge. You don't want to have any runoff error. Any single mistake or a small runoff error can actually make your bridge collapse sometime in the future. So we want to work with exact values whenever possible. In the previous chapter, we've already learned this technique. We've learned how to find the vertex of a quadratic function by completing the square. We were able to find the vertex of a parabola by completing the square. We can use the same technique in this unit. So in example number 1, I'm going to solve this quadratic equation by completing the square. In the previous unit, we would put the first two terms together and leave the constant alone. The number at the very end of the equation is not part of the perfect square, and we will leave it alone. And for the first two terms, we will group them together and take the GCF for now. So in this case, I'm beginning with x squared minus 6x inside the bracket. And minus 4, we leave it outside the bracket. As we complete the square, we will come up with a new term using the middle term. As you divide it by 2, you will be using this number here to form a perfect square. Once you've added new terms to it, you want to offset the change, and that's why we need extra space to offset the change. I will subtract it by 3 squared for this 3 times, because we are adding these new terms 2 times. We want to offset the change 2 times. Once you've added the new terms and offset the change, it is time to put it in the perfect square. Now x comes from the above, the minus comes from the above, and the plus 3, the 3 comes from the above. The rest of it, minus 4 minus 18, in this case will give us minus 22. 9 times 2 equals 18. That's how they combine to give us 22. Once we are here, we can start to solve for x. We want to solve for x, single this out, and we can do that by getting rid of this, getting rid of this, getting rid of the square, and getting rid of the minus 3. So as I move the 22 to the other side, this is what we're getting. once we're at this point, I can divide the 2 to the other side. And finally, take the square root to remove the square. And here comes the most important concept, the new concept here. Every time when you take the square root of a number, you are going to come up with 2 answers. This is how you come up with 2 solutions for your quadratic equation. We've been talking about how it is possible to get at most 2 answers for a quadratic equation. You can get at most 2 real roots for every quadratic. By having the plus and the minus in front of your square root that allow us to get 2 answers at the end. And finally, we add 3 to it. So there could be 2 answers. The first one may involve using the positive root 11 plus 3. And the second answer, it would involve the use of negative square root plus 3. So these will be the 2 solutions for this quadratic equation. Now the textbook will show us a different way to complete the square. I'll let you decide which method works the best for you. The way that they do in the book will bring the number to the other side instead. Kind of different from what we used to see in the previous unit. And then seeing how everything is divisible by 2 will undo it. There are times when the terms aren't divisible by 2 and they continue with the 2 and go to GCF from there. But in this case, they probably will do this. And then, as you are to complete the square, we need to add a new term to it. And once again, you'll be using this middle term divided by 2 to come up with 3 squared. Here is the funny part. Since we have added the 3 square on the left hand side, you will balance the equation with the same thing on the other side. So you are adding the square on both sides of the equation. This is the difference between the method in the past and the method in the book. The method that I did here and the method in the book. So the 3 terms on the left hand side becomes x minus 3 squared. And on the other side, it should be 4 plus 4. So now 4 plus 3 squared equals 9 plus 4 is 13. Wait, hang on. No. And it's actually a 2. I divided by 2. And then we will end up with 11. And then we will take the square root of 11, giving us plus or minus. And therefore, we will see square root of 11 plus or minus plus 3. That's how we end up with the 2 answers here and there at the beginning.